Hi everyone, we're going to use the principle of mathematical induction to prove that 5 to the nth power minus 2 to the nth power is divisible by 3 for all positive integers n. So the first thing we're going to do is make a conjecture based off definition of divisibility. So what we can say on our conjecture is that 5 to the nth power minus 2 to the nth power equals 3r for some r that's an integer, some integer r. All right, now we have to show that it works for n equals 1, that it's valid. So let's check that out. That's a 5. That equals 3 times 1. So r1 would be the r in this case, which is divisible by 3. So it's valid for n equals 1. And so we want to show at the very end of this that it works for n equals 2, n equals 3, and so forth for all integral values of n. So the next step we're going to do is assume that it's true for k. So write this as 5 to the k power minus 2 to the k power equals 3r for some integer r. It's just a double z. I make a z and make it double. It's called double z. All right. Now we want to prove that it works for s sub k plus 1. So write this as like this. Minus 2 to the k plus 1. Everywhere there's a k, put k plus 1. We want to change the r to some other variable. So we're going to we need a variable t that's an integer to do our proof. Now what we want to do is start here and show that we can make it look like s sub k plus 1. So if we start with s sub k, what I can do is first subtract 2k from both sides. So I'm going to do 5 to the k power equals 2 to the k power minus 3r. And then what I want to do is multiply both sides by 5. So multiply both sides by 5. I'll put the 5 in front on this one back here. This is going to be 5 to the k plus 1, which is what we want. And then for this one, I'm going to change this 5 to 2 plus 3. And this should be plus. Sorry about that. All right, and then distribute that out, and you're going to get 2 to the k plus 1. We multiply those two because 2 times 2 to the k, remember you're just adding your exponents, plus 3 times 2k to the k power plus 6r plus 9r. Now simplifying that out, what I can do is I'm going to subtract the 2k plus 1 from both sides. And we're going to get, let's see, 3 times 2 to the k plus, and we had 6r plus 9r. Well, that just equals 15r. So I'm going to write that out. It's just going to be 15r. Now let me write again what we had for our k plus 1. What we want it to look like is 5 to the k plus 1 minus 2 to the k plus 1 equals 3t for some t, some integer t. Now, I want this to look like that. So I have the left-hand side okay, but I need to write this out. So we have 5 to the k plus 1 minus 2 to the k plus 1 equals, and I'm going to factor out a 3. So you have 3 times 2 to the k power plus 5r. Now I'm going to let t equal 2 to the k plus 5r. So we end up getting 5 to the k plus 1 minus 2 to the k plus 1 equals 3t. I'm letting this be t. And we've achieved our goal in letting these two equal each other. So we have proven that 5 to the nth power minus 2 to the nth power is divisible by 3 for all integral values of n. And that's it. Thank you. Have a nice day. Bye-bye.